Hi everyone, today we are going to start 8.3, which is show that a quadrilateral is a parallelogram. First, we're going to start off with some theorems. Theorem 8.7. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So what that's saying is that if segment AB is congruent to segment CD, and we know that segment BC is congruent to segment AD, we then know that ABCD is a parallelogram. Theorem 8.8, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So what that's saying here is that if we know that angle A and angle C are congruent or the same measure, and angle B and angle D are congruent or the same measure, then ABCD is a parallelogram. Theorem 8.9, if one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. What that's saying is that if we know that BC is congruent to AD, and we also know that BC is parallel to AD, that is enough information for us to know that ABCD is a parallelogram. Theorem 8.10, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. What that's saying is that if we know that BD and AC bisect each other, then ABCD is a parallelogram. Please make sure you have all of these theorems written down in your notes. An amusement park ride has a moving platform attached to 4 swinging arms. The platform swings back and forth, higher and higher, until it goes over the top and around in a circular motion. In the diagram below, segment AD and segment BC represent 2 of the swinging arms, and DC is parallel to the ground line L. Explain why the moving platform, segment AB, is always parallel to the ground. So if we look at our parallelogram, ABCD, if it's rotating in a circular motion, we're going to see that the shape of our parallelogram or our quadrilateral changes. However, the side lengths do not change. They stay the same. And if you look at our picture here, we notice that 38 and 38, they're across from each other. They're congruent. 16 and 16, they're across from each other and they're congruent. So since both pairs of opposite sides are congruent, we know that ABCD is going to be a parallelogram. So I'm going to write that out. So once again, since both pairs of opposite sides are congruent, I should say congruent, that means that ABCD is a parallelogram. So since this is a parallelogram, we know that AB is parallel to DC. Well, we also know that DC is parallel to line L. That means that AB is also parallel to line L. The doorway shown is part of a building in England. Over time, the building has leaned sideways. Explain how we know that SV is equal to ST. In our picture, we see that ST is the same length as VU, and we also see that ST is parallel to VU. Is this enough information to prove that this quadrilateral is a parallelogram? And the answer is yes. So we know that ST is parallel to VU, and we see that ST is congruent to VU. So that is theorem 8.9 states that this quadrilateral STUV is a parallelogram. So since this is a parallelogram, we therefore can state that SV is equal to TU, and we're done. So ways to prove that a quadrilateral is a parallelogram. This is something else you should write in your notes. Number one, you want to show both pairs of opposite sides are parallel. 2, you want to be able to show that both pairs of opposite sides are congruent. 3, we want to show that both pairs of opposite angles are congruent. 4, we want to show one pair of opposite sides are congruent and parallel. And finally, number 5, we want to show that the diagonals bisect each other. So let's look at these examples. Do we have enough information to say that these are parallelograms? Yes or no? So let's look at the first example here. For this, we just know our angle measures. So looking at the angles, is this enough information to prove that this is a parallelogram? The answer is yes. Well, why? Well, we notice that the opposite angles are congruent. So I'm going to write that out. So yes, because both pairs of opposite angles are congruent. Let's look at the second one here. Is this enough information to prove that this quadrilateral is a parallelogram? Yes or no? The answer is yes. And why? Well, in this case, we're given the side lengths. We know this is 7 and this is 7. We know this is 5 and this is 5. So we know that both pairs of opposite sides are congruent. And then finally, is this enough information to prove that this quadrilateral is a parallelogram? Yes or no? The answer is yes. And why? Well, we know one pair of opposite sides are congruent and they're parallel. So that's enough information. For what value of x is the quadrilateral a parallelogram? So this time we're going to take what we know, our theorems, and to use that to solve for x. So if I look at the first problem here, I'm given the diagonals. What do I know about the diagonals in a parallelogram? Well, we know that they bisect each other. So that means that this segment is congruent to this segment. So when I set this up, I'm going to have 5x minus 8 is equal to 3x. So next I'm going to subtract 3x from each side. When I do so, I'm left with 2x minus 8 is equal to 0. Then I need to add 8. I need to add 8. That gives me 2x is equal to 8. Divide by 2 on each side. We then get that x is equal to 4. And we're done. For my second problem here, same thing, I'm given diagonals. And what do we know about our diagonals in a parallelogram? We know that they bisect each other. So that means that this segment is congruent to this segment. So that gives me that 2x is equal to 2x is equal to 10 minus 3x. I'm going to add 3x. I'm going to add 3x. So those cancel. I get 5x is equal to 10. Divide by 5. I end up getting that x is equal to 2.